Good morning. In this session, we will learn another cryptographic concept, that is digital signature and its application in blockchain technology. Now, the internet is an open and public system. We all know that we all receive and send information over shared WAN and connections. Even though it is an open system, we will still exchange a lot of private data like credit card details, our email, password, etc. So how can we keep secret our private stuffs over internet? It can be kept secret through a process known as encryption. It is a process of scrambling or changing the message into ciphertext to hide the original text. And the decryption is a process of unscrambling the ciphertext to its original text. Okay? So in cryptography, a key is a string of characters used within an encryption algorithm for altering data so that it appears random. It is like the physical key. It locks, that means encrypts the data so that only someone with the right key can unlock it. Okay. Now, there are some properties of cryptographic key. First is truly random. That means we need to generate the key truly random so that the attackers can't guess it. Okay? And the second point is sufficient length. That means the key should be of sufficient length, and if we increase the length, it makes the key difficult to guess. And third one is sufficient entropy. That means the key should contain sufficient entropy. All the bits in a key should be equally random so that some parts of a key should not be guessable. Now, the idea is very simple. The people have been doing this for centuries. One of the well-known methods was Caesar cipher, named after Julius Caesar. He used to encrypt his military commands to make sure that if his commands were intercepted by enemies, they would not be able to read it. Okay? Caesar cipher is an algorithm that substitutes each letter of an original message with a letter a certain number of steps down of the alphabet. Example, if we take the word block, B-L-O-C-K, and the step down number is 4, then the word will become F-P-S-G-O. Okay? But the problem is, everybody can crack the message by trying with every possible keys. And it will take hardly an hour to crack. Now, how can encrypt a message so securely so that they are too hard to crack? This too hard to crack means there should be too many possibilities. Okay? Now, today's secure communication are encrypted using 256-bit keys. That means if a bad guy's computer that wants to intercept your message, it would need to try so many possible options. And if you had 100 and 1,000 supercomputers and each of them are able to try a million billion keys every second, it would take trillions and trillions of years to try every options just to crack a single message protected with 256-bit encryption. But today's impossible problem will be solvable just a few hundred years in future, and maybe the 256-bit algorithm will not be enough to be safe. Okay? Now, the next topic is symmetric key cryptography. Okay? It is actually private key encryption technology. Here data is encrypted using a single same key that only the sender and receiver know. Private key encryption is also known as symmetric key encryption because the same key is used in both encryption and decryption of the data. To explain this, let me introduce a typical example of Alice and Bob. Bob wants to send a lovely message to Alice. He does not want anyone else to see it, so he encrypts his message. Well, that is easy because Bob shares same key with Alice. So they uses same key to encrypt or decrypt the message. The main drawback here is the chicken and egg problem of sharing the secret key. Without a secure channel, the key cannot be shared, but without the key, no secure channel can be created. So you have to need a way to get the key to the party with whom you are sharing the data. Now, in asymmetric encryption system, user generates a key pair, a public key and a private key. The public key and the private key are associated with each other through some mathematical relationship. The public key is meant to be distributed publicly to serve as an address to receive message from other users. It is like an IP address or home address. Okay? The private key is meant to be kept secret to the user only. Now, here is an example. Bob is sending a lovely message to Alice, and they agree to use public key encryption to encrypt his message. Here, the encryption process starts with receiver Alice. Now, how does it occur? First, Alice creates a pair of keys, one public key and one private key. She keeps the private key with her own and put the public key in a public key server which anyone can access. And Alice also informs Bob that from where he can get her public key. Now Bob gets her public key. After that, Bob writes his message. He uses Alice's public key to encrypt it. And when Alice gets this message, he uses her private key to decrypt the message. Please keep in mind that the public key encryption method is started by the receiver, not by the sender. That means the receiver will generate the pair of keys. Okay. Now, although Alice's private key verifies that no one can change or read the document during transport, but it cannot verify the sender. Okay, because Alice's public key is public, anyone can use it to encrypt his document and send it to Alice while pretending to be Bob. Okay, so in order to prove the sender, they need another technique that is called digital signature. Now, what about digital signature? It is like a real signature, and it is a way to prove that originated from whom. It is more secure than handwritten signature that can be easily forged. Okay? And digital signature, actually it is a way to prove that the message originates from a specific person. Digital signatures are used today all over the internet. Whenever you visit a website, you are using SSL, which uses digital signature to establish trust between you and the server. This means when you visit gmail.com, your browser can check the digital signature that came with the web page to verify that it is indeed a Gmail server and it is not by any hacker. Now, digital signature mainly serves three purposes. First is authentication. That means a digital signature gives receiver reason to believe the message was created and sent by the claim sender. Second point is non-repudiation. That means with digital signature, the sender cannot deny having sent the message later on. And the third point is integrity. That means a digital signature ensures that the message was not altered during transit. Now, digital signature is used mainly software distribution and in financial transaction where it is important to detect forgery and tampering. And digital signature, it is actually a public key encryption technology. Here, the message is signed using the private key, and again, message is verified by the public key. Now, let me introduce the Alice and Bob's example to demonstrate that how digital signature works. Now, first, Bob generates two keys, one public key and one private key. Now, Bob keeps the private key and gives public key to the receiver Alice. Now, first, Bob creates a memo, and after creating the memo, Bob generates a digest using hash algorithm. Now, Bob encrypts the digest with his private key using asymmetric cryptographic algorithm. Now, the encrypted digest is digital signature for the memo. Then, Bob sent both digital signature and memo to Alice. While Alice received that, she will do two things. First, Alice will decrypt the digital signature using the public key of Bob and get the digest. If Alice failed to decrypt the digital signature using the Bob public key, then it is confirmed that this is not Bob's digital signature because only Bob's public key can decrypt the digital signature to get the digest. Secondly, Alice will check the integrity of the memo. For that, Alice will hash the memo by the same hash algorithm and generate the digest. Now, Alice will compare the generated digest along with the digest received. If both matches, then it confirms that the memo is not altered after Bob sent it. But if it does not match, then the memo has been altered in transit. Okay. Now, in blockchain technology, the generating a key pair is analogous to create an account on a blockchain, but without having to actually register anywhere. Also, every transaction that is executed on the blockchain is digitally signed by the sender using their private key. This signature ensures that only the owner of the account can move money out of the account. So this is the concept of digital signature in blockchain technology. Thank you.